Good morning class, I am Govind Vyas from Cambridge Convent School, Bikaner. As you know, in a previous lecture, we studied about types of power plants. Today, we are going to discuss two of the topics named dissipation of energy and another is the methods to reduce the dissipation. Clear? So, the first is dissipation of energy. What about this? What is dissipation? Okay. Understand this thing that you must know about the law of conservation of energy. I will discuss it with you in the next lecture. What is the conservation of energy? It says the energy which is available in this universe is of a certain quantity. We cannot add more energy, we cannot subtract any energy from that. That means to say energy can neither be created nor be destroyed. It can only be converted from one form to another, right? We shall discuss it in details in the next lecture. But what does it say? That always one types of energy can be converted into another types of energy. Clear? Any one kind, maybe that the kinetic energy is available to us, but we require electrical energy. What will we do? We shall convert the kinetic energy by any process into electrical energy. The conversion will be done. Okay. So the condition is we have any energy. I am writing here one. That says any first kind of energy is available to us. What will we do? We will do some conversion process. Conversion of energy. What after conversion? We shall get energy of second type. But there will be something another also. What is that? Not used energy. Not used energy. What does this equation say? It says that we had a certain one type of energy. We did some conversion process, and after the conversion, we got another type of energy. But with it, we also got some amount of energy which was not used. What is this? This can be said to be in simple words the dissipation of energy. This can be said to be dissipation of energy. Let me explain it with you. Suppose that you must be clear with one thing, that ideal condition never exists in science. Ideal condition never exists. What does I mean to say? Let me explain it now. Suppose that I had some certain amount of energy, say 100 joules of energy. I have 100 joules of energy. Let me say that I have 100 joules of kinetic energy. I have 100 joule of kinetic energy. I want to convert that 100 joule of kinetic energy into any other kind, say electrical energy. I want to convert it into electrical energy. So I will do some conversion process. I will do some use some coal power plant, hydro power plant, wind power plant, some kind of power plant. Any conversion process that we have already discussed, right? So I have 100 joule of kinetic energy. I did some conversion process. Okay. During conversion process, what happened? Does this 100 joule of kinetic energy will completely convert into 100 joule of another electrical energy? Never. If 100 joule of kinetic energy completely convert into 100 joule of electrical energy, this is said to be an ideal condition. But in reality, it never exists. In actual condition, there are always some losses. This 100 joule of energy may be that if the system is very efficient, I am getting for example say 70 joule of energy. Out of 100 joule of kinetic energy, only 70 joule of kinetic energy, 70 joule of electrical energy was obtained. What about the remaining 30 joule? The remaining 30 joule is here, which was not used, which went into environment as a waste. We could not utilize that. So this 30 joule was basically can be said to be waste. This is known as dissipation of energy, or in simple words we can also say that in every process of energy conversion there are always some energy which is normally never used, which cannot be utilized for our any purpose. So that waste of energy is basically known as dissipation of energy. I hope it is clear to you, right? I will explain you in the later on with some examples. So there are some three types. There are basically three types of dissipations in our syllabus. The first kind is dissipation of light energy. Second is dissipation of sound energy. And the third one is dissipation of heat energy. We shall study this theoretically now. Okay. The theory is given in your book. I am just explaining it to you, to make it easy for you. So what is the dissipation of light energy? Okay. Firstly, understand this, that there are some processes in our day-to-day life every day. Some examples are there. Some processes are there in which light energy is produced. Right? In some processes, light energy is for our use. But there are some processes in which light energy is produced, but we have no need of light at that particular place. Some places are there where we require light, like in this bulb. I require light in this room. But there are also some processes in which light energy is produced, but I have no use of that light at that place. Where, take an example, in our kitchen, when we cook our food, then there is some flame, right? There is some flame on the stove, etc. Gas, there are some flame. That flame is used basically for the cooking. But due to that flame, some light is also produced. Do we use that light? I think we don't use that light. That light is not a purpose for making the lightning around us, right? Brightness around us. That there only heat energy is used for cooking, but light energy is also produced, but we have no use of that light. So what is that? It is not a use, it is dissipation of light energy. That is only a waste of light energy. We are not utilizing that light. Clear? Okay. So that is the light energy. Dissipation of light energy. One of the example. Okay. Second is sound energy. There are some also certain processes in which sound energy is produced, but we have no use of that sound. So if we have no use of that sound, that is known as dissipation of sound energy. Some examples may be there, like we must take the example of our automobiles, our vehicles, right? Or I can also say the example of in summer we are using the water cooler, etc. So when you are using a water cooler at your home, suppose you are sleeping in the afternoon at your home, at night at your home, and you are using a water cooler for cooling of your body. Then the water cooler gives you cooling, right? The water cooler gives you cooling, but that cooler also produces some sound. The motor of that cooler, the rotating fan of that cooler also produces some sound. Do you use that sound? Is that useful for you? No, I don't think that is useful for you. You do not dance on that sound. That is not a rhythmic, or that is not a music sound. So you will use that. That is just a waste. You have no use of that particular sound. Or take another example of automobile, may be the best example in which we study this chapter. What is that regarding the sound energy? When you are riding a bike, when you are on a vehicle, then you are just using for that going from one place to another place. But when you ride your bike, when you use your motorcycle, then what happens? The engine of that vehicle also produce some sound, right? The engine produce also some sound. Do you use that sound for any use? No, that is just going to be a waste. So that may be said to be a good example of dissipation of sound energy. No use of sound energy out there. And what about the last one? Heat energy. Similarly, like these two above, there are some processes also where heat is produced, but we do not have any use of heat at that particular place. Where can that happen? Take an example of your bulb, right? I am talking about the traditional old bulbs used to nowadays CFL types of advanced bulbs are used, but some of the years back, if we go, or still in some houses, those are used. The round bulb which is used elliptical shape. What about that? When you touch that bulb, suppose that I have come into this room, I light up that bulb, and after 1 hour I touch that bulb. Do I feel heated? The temperature of the bulb is very high, right? The temperature of bulb is high. I will feel some uncomfortable when I am touching that bulb. What happened there? Heat was produced. But do I use that heat? No, I have no use of that heat at that place. The bulb is made only for the light energy, but heat energy is also produced there. Do we use that heat for any use? Do we use that heat for cooking? Do we use that heat for heating of our body in the winters? Absolutely not. So there only light energy is a useful thing, not the heat energy. But in spite of that, it is being produced. So it is a dissipation, or I would say that is the waste of heat energy, right? Again, I am taking the example of automobiles. When you are using your vehicle, bike, scooty or car, four-wheeler, etc. Suppose that I am here, I am riding the bike and I have reached my home. When I reach my home, bring your hand near the engine. Don't touch it, just bring near to that. You will feel something heated. Yes, the temperature of your automobile engine is heated, high. The temperature is just high. So, do you use that heat energy for cooking your food? Will you put any container for cooking your food on that engine? Absolutely not. Do you use that engine for heating of your body in the winter? I think don't. Do you use that heat for heating the water? No. You have no use. Absolutely. I mean to say, we have no use of that heat, right? We have no use of that heat. That is going in environment as a waste, right? Okay. So in this way, we can say that there are some also places where heat energy goes as the waste. So if the energy is going anywhere for as a waste, we have no utilization of that energy. That is known as dissipation of energy, right? It is not a good thing for us. The more dissipation, the more losses. The less dissipation, the fine. Now we are discussing the actual conditions of energy dissipation. What do I mean by this particular name? It means that electrical energy, we are talking about the electrical energy because that is the type of energy we used in the bulk content, most content, right? Okay. So from the generation of electricity to the last use of last point where the electrical energy is used, up to that lots of losses are there, lots of dissipations are there. So we are talking about those losses in this topic, right? Okay. What happens first? I am explaining you with the help of a block diagram. At the first, the generation of electricity takes place at a certain power plant. So let me give an example of one type of power plant, like a coal power plant. Firstly, lots of water is in boiler. What is boiler? I explained you in the previous lectures in coal power plant. Boiler is a very giant structure in which a huge amount of water is placed, and in the downside of that there is lots of coal. The coal is burned. Due to burning of the coal, the temperature of the water rises, and that water then converts into steam, right? Okay. Boiler. Or I can also write it properly: heating of water in the boiler. Okay. The sequences of losses starts at this point. Heating of water in the boiler. What happens in the boiler? There is a lots of huge amount of water downside. The coal is burned. Why are we burning the coal? To provide the heat to the water, right? we are burning the coal only for the purpose of heating of water. But do you must be familiar that not only just water is heated, not only just the heat is transferred to water, the walls of the boiler also gets heated. It is as similar as we have a container and the water is put inside that. We have just flamed the water, right, by the stove, by the gas, etc. We have just flamed it downside that. When we try to heat the water, just only water gets heated? No, the container also gets heated. So do you have any purpose of heating that container? No, our purpose, our main motto was just to heat the water, not the container. So this is a loss. Our heat which was supposed to go only to the water, it has gone also to the container. It is a loss. So first loss started here. What kind of loss? I will write it here. Loss of heat energy. Yes, loss of heat energy, because only water was supposed to get heated, but the walls of the boiler are also got heated. This is a loss of heat energy. That heat energy which was used to heat the walls, if those were used to heat the only water, lots of coal would be saved, right? Okay. So first loss started here. Now what happens? After water gets converted into steam, it goes to the turbine with the help of pipe, nozzle and many arrangements. Ducts. Okay, I will write steam flowing in ducts. Ducts are basically pipes. Okay, what happens here? It is a very high temperature steam which is flowing through pipes, through ducts. And take one thing, if the steam, the heated steam, very high temperature steam is passing through the pipes, the sum of the temperature will, some of the heat will be transferred to the pipes. When suppose that this is the pipe, a very high temperature heated steam is going through this. When I touch this pipe, I will feel heated. That's obvious, right? So that means that heat of the some part of the heat of the steam which also got transferred to the material of the pipe. Now this pipe is heated. Do I have any use of this heated pipe? No. It is just waste of heat energy again. Again, loss of heat energy, because the pipes and the ducts got heated and we have no use of that. After this, the steam goes where? To the turbine. Turbine and generator. Turbine and generator. Right? The steam goes to turbine, it rotates turbine, then generator gets rotated. And you must know that where there are mechanical parts, some parts that does motion, there is always some friction. Lots of energy is wasted in friction also. So there is loss due to, that will be an appropriate, due to friction. Some losses in the form of friction, right? Now what happens? After the generator, electricity is produced, and that electricity by the wiring arrangement is transferred to our houses. That means after generator, what are the physical apparatus? Wires. Wires. Okay. Now after generator, lots of wiring arrangements are done, poles arrangement are done. From that, through that, the electricity, those are the medium from which the electricity from a powerhouse comes to our residential house. Right? So there are lots of losses where electricity is flowing through the wires. What kinds of losses? Heat loss is there. loss of charges are also there. Suppose that there is a certain type of energy, certain amount of energy, I am taking the magnitude like 100 electrical energy is transferred from here at this power house, and this is our house. This is long wire, a long series of wires and poles. Then what happens? 100 is here, 100 will not reach here, something will be deducted, something will be lost. What is that? Due to charges. When the electricity was passing from here to here, lots of charges got emitted in the environment. Okay. So this is also loss of heat, because wire also gets heated, comma, charges. Loss of charges also takes place here. Okay. Now the electricity by wires came to our house. Now the point is our house. In our house, many electronic appliances are there. Many appliances are there, and in every appliance there is some certain type of loss. Like in a bulb, heat loss is there, right? In refrigerators, there is also heat loss. In the fan, when the fan rotates, it gives us cooling, but the motor of the fan, yes, they also gets heated. So there is also some losses. In houses, different types of appliances are there. So different losses also occur there. So I will write miscellaneous losses. There are lots of different losses. So see at how many places energy is getting wasted, at how many places dissipation of energy takes place. Starting from the point 1 of generation of electricity to the last place where we use the energy, consume the energy. Till that there are lots of losses. That is why electricity is so much costly, because suppose that I am producing a certain type of energy, but what I get is very less, so I have to use more. I will use more. If I use more, I will have to pay for more. The electricity is produced here. I am taking an example, the magnitude of 1000 magnitude electrical energy produced here, but what will reach here? Only 400, 300, because lots of losses are there. So you can take this as a condition of losses or dissipation of energy. So next we are going to discuss how to reduce the dissipation of energy. Okay. So alright. So far we have discussed about the dissipation of energy. Now we are going to discuss about reducing the dissipation. What are the methods? What can we do to reduce the dissipation of energy? So I have written some of the things here, some of the short forms here, that what should we do to reduce our energy dissipation, right? Because energy dissipation is basically the loss to us. So we must always try to eliminate. We cannot completely eliminate, but we can reduce them up to maximum extent. So we must do that. So these are some of the ways to reduce the dissipation of energy. They are very easy things. So what those are, let's study. Okay. First, these are very easy. First, switch off. What to switch off? All the appliances. You can write them without any guidance also. Switch off all the electrical and electronic appliances when they are not in use, like fan, bulb, air conditioner, and many more electrical and electronic appliances. When we are not using them, switch them off so that electrical energy can be saved. Like, right? Suppose that we are not using the room, so we must turn off the light so that light energy can be conserved. It can be saved for next generation. Okay, fine. Similarly, power rating is another way to reduce the dissipation of energy. Now, what is the power rating? If you have visited any, you must have visited any electronic shop to purchase any washing machine, refrigerator, air conditioner, so many things, right? So when you visit that electronic shop, then you see that on every electronic appliance, star ratings are written on them, 5 star. 4 star, 3 star, single star, right? So you must always purchase the electronic appliances rated with 5-star ratings. 5-star ratings. 5-star rating appliances are best to use because they consume less energy and gives us more output. Fine. So we must always purchase the 5-star rating appliances. This is known as power rating of the electronic appliances. This is also a way to reduce the dissipation of energy. Electrical energy will be wasted less and we will get our desired effect more. Okay, suppose that you are purchasing an AC, one AC is of 3-star and another AC is of 5-star. The 5-star AC will give you more cooling, consuming less electricity. And what about the 3-star AC? It will consume more electricity, means your bill in rupees will be more, but cooling effect will be lesser. Okay, so that is what I basically want to say. What is next? Use LED and CFL types of bulb. Whenever you are in olden times, we used to use the round or bulbs of a traditional ways, but nowadays. So what is basically LED and CFL do? These are the new modern technology bulbs, and what does they do? They consume less electricity, they consume less power and gives us more brightness, more light energy is provided to us. So we must always use these LED CFL bulbs rather than we used to do, we used in our houses the bulbs of a very big sized bulb in 2-3 years, many years back, right? Okay, so LED CFL bulbs are the alternative solution of consuming or reducing the dissipation of energy. Okay, next, what is this resistant design? It is meant for our houses. Okay, our house design, home design must be something like this, that in winter we must let's talk about summer. In summer, our house design, the material we use for building the walls of our house, like bricks, we must use bricks whose material is bad conductor of heat. Bad conductor of heat. Bricks should be used of a material which is bad conductor of heat. What will happen from this? Oh, what will happen? Let's see. This is the wall of the house. We are the people living in this side, and this is the side of where from sunlight comes from, right? Okay. If the wall between the sunlight or heating, I say heating, and us, the material between this is a bad conductor of heat, then it will not allow the heat to come inside our house. The heat will be stopped here, but it will not be transferred inside the house. Then what will happen? We will not use that much heated, and we will not have a need to use our AC at full capacity, right? Because we are not feeling that much heated. But if it is an ordinary material, or it is not a bad conductor, it is a conductor of heat, then what will happen? The sunlight, the heat energy of the sun will come inside the house, and we will feel heated, uncomfortable, and we will use the air conditioner at full capacity. We will require that heat. We will require the air conditioners in full capacity, right? So what we are supposed to do? We must use the house design appropriately. That means some materials of which we use should be of bad conductors of heat, so that we can eliminate some of these things by natural way. And what about in winter? Similarly, some certain types of designs can be taken for the winter also. Okay, so these are some sort of examples that to reduce the dissipation of energy. And what now? In some are the basic things which you can write on your own, like what petrol, diesel, fuel, CNG, LPG. These are also some of the kinds of chemical energy. These types of energies must be saved when you are standing on the traffic light. You must not keep your vehicles in on mode when you are standing on the traffic light. When your vehicle is in ideal condition, its engine must be off so that energy dissipation must be reduced, right? So these are some of the types of things which you can use to reduce the less